So hello everyone. Today we are going to discuss about the Spark basics. In the last session we talked about the introduction to Spark, and then we talked about the Spark logical architecture. So now in the today's session we are going to talk about the Spark basics. What are the things we should know before embarking into the Spark details? Okay. So first of all, in the basic we will talk about the Spark shell. What is a Spark shell? Right. So as you know that we have already discussed during the demo session that how we can start the Spark shell. So that Spark shell actually provides the REPL. That means the Spark will give you the REPL. That is read, evaluate, and print and loop. That means it's provide the interactive data exploration. Right. Now you can say that Spark shell is actually this Spark shell is written in Scala. This is actually your Spark application. This is a small Spark application which is written in Scala. Okay. Now you have seen that the Spark shells just give you the command line environment with the auto completion features. With auto completion, that means you can press tabs and then it will uh, auto complete the functions, whatever the function you have given that. Now in this Spark shell you can run ad hoc queries, and these ad hoc queries you can run through Spark shells. Okay, and definitely we're going to see these queries during the lab or during the demo sessions. And this Spark shells are in Python, and in Python we have PySpark, and in Scala we have Spark shell. Right. Now now we have you can say this Spark shell is, you will see this Spark shell is just like an extension, you can say is an extension of you can say Scala REPL. So you have done Scala, then this is also just like an extension to Scala. And the very interesting thing about this Spark shell that you will see the automatic initialization, you can say initializations of the variable like uh, Spark session and Spark context. Spark session you have not seen, but we will discuss, and that's comes with the word called Spark. The Spark session internal implicit or by default variable is Spark, and you have uh, Spark context. So these two variables, which is called with the name SC. So these two variables like SC, and which is a Spark context, and the variable called Spark session, these two variables are automatically initialized in the Spark shell. Okay, so now you can say that this is actually a tool to analyze the data. Okay, so you will analyze the data interactively. Okay, so this is about the Spark shell. Now in the Spark shell we have seen Spark context and Spark session. So let's talk about the Spark context. So now let's see what is a Spark context. So now in any of the program we have the entry point, like in the Java programs or in other program we have the main programs like that. So you can say that because we are using interactive shells, this Spark context, which is called SC, is your main entry point. It's a main entry point to Spark functionality, right? So this is the main entry point to the Spark functionality, because it will give you, or it will just like it will act as a handler, and it will give you the opportunity to work with the Spark, and you can interact with the Spark cluster also. And you can say that this represent the connection to the Spark cluster. Now with this Spark context you can get the current status of your Spark application, which is written in Spark. Okay, and what you can do with Spark context, you can set the configuration. So that means you will give the configuration setting also, and this is pre-configured. What does it mean? That means this SC variable is pre-configured in shell with the name called SC, which you have already seen many times. And but when we talk about the shell, but I'm saying this shell, it is pre-configured, but let's say you are writing some application of Spark, either in Python or Scala. So in application, when we will create an application, the way you created in MapReduce, okay, when you create an application not in the shell, then we need to create explicitly. So we need to create explicitly this Spark context, and we are going to see this also. And with Spark context, you will going to create, you can say RDDs. You will create some broadcast variable. I'm just going to discuss broadcast variable later on. These are the some you can say core level variables, and accumulator also. So just please remember these name, but we are going to discuss this in detail. Now other thing about the Spark context is that this Spark context, that means this SC will be per JVM. This is the per JVM. So in a JVM we have a one SC. Okay. This will allow application to access Spark cluster, right, with the help of some, or you can say it will allow application to access Spark cluster with the help of your resource manager. So with the help of resource manager. And one more thing is there, this Spark context was being used before the 2.0 version. You can also use in the later version also, but after that the new you can say new variable came into the picture called Spark session. So this was being mostly used in the before 2.0 version. Okay, now let's talk about the Spark session. Right now, this Spark session was introduced in 2.0. So then you can also say that this is also like an entry point to Spark functionality, to what, to create RDDs. You can create data frames over there, and we are going to discuss everything in detail. Don't worry. For the time being, just remember, and this is a data set. So these will be there to create all those things, and this is available default. That means this is a default which is available in the shell. So default in the shell, this is also available, and with the name called Spark. This will be a name. The name just like an SC, like I'm just writing like SC. It is also default available. I'm just marking these two. Okay, now you can create this Spark session using, you can create Spark session using builder pattern. There are builder patterns are there, so you will use these builder pattern to create this session. Right now we will see how we can create. So just like I'm just taking a variable called Spark session is equal to Spark session name dot, like you can use builder dot, let's say we have a lot of configuration, so we will see discuss. So master you are using local, I'll just tell you not right now, but master you are using the local dot. Let's say you want to give an application name, app name, and you're giving, let's say, hello world or hello, and dot like configuration, you can set some configuration over here. Then dot last is get, O is capital, or create. So you can call this function. So this through this way we can create the Spark session. Okay, now this Spark session is actually a one-to-one, you can say, relationship. Okay, so this is a one-to-one relationship between your Spark session and your Spark application. So that means there will be one Spark session in a Spark application. In the earlier version with the 2.0, we were having some more variables, and those variables were there in the 2.0 like SQL context or Hive context. But now those two variables can be replaced with this Spark session. That means Spark session is actually replaced with SQL context, just like a Spark context, or to use Hive. There was a Hive context variable was also there, and that was prior to 2.0. But backward compatibility is always there. Now in the new session we are going to see Spark session, but we will start with Spark context first. We will see some programs or some labs in the Spark context, and after that we will move to the Spark session. Okay, so now let's talk about some toolkit. So let's say what the toolkits looks like, Spark toolkit. So now what happens, like if we see the different perspective of the Spark architecture, is like we have some low level APIs. Then let's say we have some middle level, and then we will make some top level. Okay. On the low level, we have a low level API, and those APIs are like RDDs. We have just started in the last session, and some are the distributed variable. When I say distributed variable, I mean to say that accumulator and broadcast. On the middle one, we have some structured API. When I say structured API, we have data sets, we have data frames, and we have a SQL also. So we can also use SQL within that. On the top of this, we have a structured streaming. Then we have some advanced analytics. Okay, and then we have libraries and some ecosystem corresponding to this whole. So this is the toolkit we have. Now let's talk about the execution modes. Or you can also say that deployment mode. How we can deploy the Spark application. Okay, so in Spark we have three different modes. So just we'll discuss one by one. First is your cluster mode. Okay, so now before that you should know few terminology just to understand this. We have drivers. Okay, so driver is just like which actually run the programs. Okay, which is actually your you can say, let me write formally. Driver, what is a driver then? The two things we should know. Driver is actually, you can say, a JVM process. Driver is your JVM process that coordinates your worker in the cluster and your execution of the task, how you are executing. Right, the two things are there. So second thing is executor. So executor is your agent which is responsible for your executing a task. There will be a lot of executor just like a mapper and reduce the task. So these two things will always be there. Okay, we will discuss in detail gradually, but just to understand the cluster mode, we should know these two things, driver and cluster. So now you can see that in the cluster mode, drivers and executor both are running inside the worker node, right? So the executor which is actually running, as well as the driver which is your JVM process, which is actually coordinating the between your execution of the task and the worker, right? So this is the very important and the cluster mode. So now what happens? This Spark jobs will run, or you can say Spark job will launch driver component inside the cluster. Okay. Now here the cluster manager, which is the manager for this whole cluster. Cluster manager is responsible for maintaining. The cluster manager is responsible for maintaining all the Spark application related processes. Okay, so this is the duty and this is the responsibility of the cluster manager to just maintain all the Spark application related all the processes, right? And this cluster mode is used in production. So whenever you will start working on in the real world scenario, then you will use these kind of cluster mode. Okay, and in this cluster mode we can say that fire and forget. The meaning of fire and forget over here is that you can launch applications and then you can leave the application keep on running, and the result will either come to the logs or the results of that particular application will save the data into HDFS or any local file system or any file system, right? That means here in this application we'll just fire and forget. But when we use shell, we just, if you execute any of the application or small thing, the result will come immediately. That is an interactive mode. Okay, now the question arises, when should we use? So when to use this mode? Okay, so now there are few scenarios where we should use. Now if your application, or if you submit an application from your machine that is far from the worker node, okay, so first scenario you can say that when application which is submitting, or application from where you are submitting, okay, that machine is far from the worker node, then we have to use this cluster mode first, because we are using, or this cluster mode is executing task as well as the driver inside the cluster. That means in when we need, or when we need to minimize the latency, when we need to minimize the latency, right, between your driver and your executor, then we have to use this cluster mode. So why minimize the latency? Because the driver as well as the executor are within the cluster, that means within the node of the cluster, worker node of the cluster. Or in the scenario where if we want a job, if job is running for a long, right, for a long time, and we don't want to wait for a result, we don't wait for result, in that scenario we should use cluster mode. Okay, so now let's see from the diagram perspective, right. So this is your cluster, this is your worker node, so this is your master, let's say this is your master, and this is your worker 1, worker 2, and this is your worker 3, worker 2, worker 3. Okay, so these are whole cluster. And now you can see, now you should know that in the cluster mode, let's say we have driver as well as executor. So I'm using the executor with a shaded one. So this is your driver, and which is there in the cluster itself, and these two are executors, right. So now you can see this is there, and cluster manager is running over here. So this is your cluster mode, right. So next is your client mode. So in the client mode is driver is outside the cluster, that means some local machine, okay, but the executor runs inside the cluster, okay, the cluster, that means where worker node. Now you can think that with the name suggests, like the driver is like client, because it's outside the cluster to the cluster, that means driver is just like a client to the cluster, that is why its name is cluster client mode. And here the problem is the entire application depends on the local local machine, because your driver is there, and without driver it will not run. That means drive where the driver resides. You got my point? The entire application depends on that machine where the driver resides. Now just to better understand, let me draw this thing. Let's say we have a cluster manager. So this is your cluster manager, which is your, you can say, master, and we have a, this is worker 1, worker 2, and worker 3. Okay, now in this we have executors, and don't worry about the executor, we will see this again and again, no problem. So these are executors, right, and obviously these are connected. Now we have some client program. Okay, so we have some client program, and in the client program we have driver here, which is outside the cluster. Okay, so this is a part of the, this is a cluster. This is a local machine, as I told, and completely heavily depend on the local machine, because your JVM process, and what is the task of driver, it will coordinate with the executor and the worker node just to execute, because application just like an application master. Okay, and this is not suitable for production, not for production, because only dependent on the local machine, but it is very good for testing and debugging, right. And you can see this client machine is responsible for maintaining the Spark driver process, maintaining Spark driver process, and On the other side, cluster manager maintains executors process, right? So this is about the client mode. Third is the local mode. In the local mode, this local mode runs entire Spark application on single machine, right? And just to achieve the parallelism, because we have a single machine, how we can achieve the parallelism? Just it uses thread to achieve parallelism, right? And this is also very good for learning, and we are going to see this learning Spark, even test application, or some do some kind of experiment iteratively, okay, with a local development. But it is not good for production, right? Because everything runs locally. There is no node concept, because there is only single machine. There is no node concept. Even there is not a concept of distributed, because we are using only single machine. The best example of this local mode is like you launch Spark shell, okay, that is a local mode, because when we launch a Spark shell, that is a single local machine and this is a local mode, okay. So this is about the local mode. Let us understand a few more details about the Spark basics. So let's say we have Spark manager, or you can say cluster manager, sorry. So we have a cluster manager, or you can say this is your architecture of Spark application, high level architecture to understand. So we have driver process. This is your driver process. So in this driver process, you have a Spark session or Spark context, depends upon which what you are using. And we have a user code also, user code to execute things. And you can interact these two like this, and this will interact with the cluster manager, right? And executor are here, different executor. Let's say we'll draw two executors. These are executors. We will get into the detail of the executor when we will start learning the Spark application, how to run the Spark application, but I am just giving you the very high level idea, okay. So in the beginning, we will start with RDDs, then we will go to the data frames, okay, and then before that we will see that how to run an application. We will use both interactive mode as well as the application, how we can submit the application. So this is your you can say Spark architecture for this application I'm talking about, not Spark architecture. It's a architecture of the Spark application, okay. Now we can also see this different perspective. I'm just showing the different perspective. So let's say if I want to show you the relationship between the Spark session and the Spark language APIs, so we can draw like this. This is your JVM, okay. In this JVM, we have a Spark session, and this Spark session is calling to many executors. So these are executors, and this is your Python process, or this is, let's say, this is your R language process. We have R language also. So now this Spark session will interact with this, right? So you can see this. This is a relationship. This is a relationship between your Spark session and Spark language API. Okay. So guys, this is just a different perspective to understand the executors and driver process. Okay. So you just understand driver is your JVM, which will help in executing, and that will coordinate your executors, and then resources will be provided by the workers nodes in the cluster. So last topic for the days is, so now let's discuss about the what is the difference between your MapReduce, as you have done MapReduce earlier, and Spark. So let's see the difference between the MapReduce and Spark. Okay. Now most of the things you already know that, but I'm just trying to sum up all the things together. So MapReduce is your batch processing, whereas Spark is your batch as well as stream processing. In MapReduce, you use a lot of code that is called boilerplate code, but in Spark, we have very less line of code. MapReduce are little slower, that means processing is slow, whereas in Spark, this is 10 to, let's say, approximately 100 times faster as compared to MapReduce. You can say MapReduce is your local disk based. Scala is your in memory based. When we use disk, that means it is having a less cost, but it is little costly as we are using memory. Now, very important thing about the MapReduce is, like, let's say when we use fault tolerant, when we are using a fault tolerance, and it uses a replication approach to create a fault tolerance, whereas Spark uses RDDs, resilient distributed data sets, for the fault tolerance. It is written in Java and it is written in Scala. Now, there is no interactive mode, but we have interactive mode here, either through Shell, Scala, or PySpark. Basically, we use Java language mostly, or we use sometimes Hadoop streaming, different processes in the Hadoop streaming. Here we can use many user-friendly APIs. What else we can discuss about the MapReduce is, MapReduce is not a real time. It is not real time, but it is real time, or we can say near real time. I think we should use near real time. That is much better. So it is near real time. So when we process it, a latency is very high in MapReduce as it is low, but in Spark, low latency as compared to MapReduce, right? But for real time, what we can use Storms. We can use SQL over here, but we have to call through Hive, and we have to take use of other project. But here we have Spark SQL, okay, where we can use SQL through Spark SQL. Different languages we can use in MapReduce is Java or C or C++ or even Ruby, if you remember. We Python also, Perl also, if you remember. Here we can use Java, Scala, Python, R, and SQL. I'm putting in the SQL also. To make it more clearer, we can say that it's a data processing engine, and we can say that this is your data analytics engine, which is a choice of data scientists nowadays. Okay, what else we can discuss? I'm using this space. What else? There is no caching. Here we have, I'm just using this space. Supports caching. For scheduling, MapReduce have to dependent on like tool called dependent on Uzi. If you remember Uzi, again Apache. Uzi is your workflow management. So scheduling means I'm talking about workflow management. But Spark is having their own scheduler, and that is a part of the Spark core. We can say that we are doing analytics through map and reduce. Here we have a lot of stuffs called like ML, streaming, graphs, complex analysis. Okay, so that's all, guys. Thank you very much for this session.